Good afternoon. I hope yesterday went okay with the area. Today we're going to do volume. So again, something probably not entirely new. You've learned volume in probably middle school, especially this first problem. This is just the volume of a prism, a rectangular prism. And you guys know this probably as length times width times height, which that is accurate. However, I want to draw your attention to these formulas over here. This is what is on your air reference sheet. If the sub passed out those laminated blue sheets again, this is on the back upper right-hand corner. Notice you do not see length times width times height. Instead, you see this capital B. It's the area of the base times the height. The reason for that is because the base doesn't have to be a rectangle, and you're going to see that on our next one. Our next one is also a prism, but it's a triangle. And you guys do have notes to follow along with this, so hopefully you see those and the sub passed them out. But this is what you are given. So again, keep in mind that this capital B stands for the area of the base. Again, in this problem, our base is a rectangle, and we have a 12 by 5 centimeter rectangle. So when I go to do our volume for this, the area of that base is just going to be 12 times 5. It's length times width, or base times height. And then the H here in our formula stands for the height of the actual prism. Like, how tall is this actual shape? So vertically, this shape is 6 centimeters high. So when I multiply, I'm going to put units, 12 centimeters times 5 centimeters times 6 centimeters, I get 360 cubic centimeters, or centimeters cubed. And this is my final answer. So we did the area of the base, 12 times 5, times the height of this prism, which was 6, and got 360. Again, this is volume, so our units are now cubed. Our next example here is a triangular prism. How do I know it's a triangular prism? Because the base is a triangle now instead of a rectangle. We're still using the same formula, the area of this base times the height, but it's going to look a little bit different because since our base is a triangle, capital B is going to be the area of a triangle, which is half base times height. And then we're going to do times the height of the entire prism. So this triangular base, the top and bottom, obviously, hopefully you realize this, are identical. So if this top is 6 kilometers, this bottom is 6. If this length is 8, this length is 8. So we have this triangle as our base. You have to remember from yesterday that the base and the height are the two lines that make a right angle. So you're not even using the 10 in this problem. When you do base times height, it's going to be the 6 times the 8. So in our formula, we have 1/2 the base, so 6 times the height of our triangle, which is 8. And so that's just finding the area of the base. Now we have to plug in the height of this actual prism. So up and down, this shape is 6 kilometers high. And in a calculator, you're going to do 1/2 times 6 times 8 times 6, and you get that this volume is 144 cubic kilometers, and that is your answer. So this is probably the biggest mistake I see is students don't truly get what the capital B means, and this whole entire part here, the half base times height, is the capital B. That changes depending on what this base is, so just keep that in mind. Our next one is similar to the composite area from yesterday. This is what we call composite volume. Notice we have two shapes. We have a rectangular prism down here, and we have a pyramid up here. If you didn't know this was a pyramid, some people get it confused with the triangular prism. A triangular prism, though, has a flat top and bottom that are triangles, whereas a pyramid has a flat bottom and it all comes to a point. So just keep that in mind. So we're going to have to find the volume of both of these and then add it together, just like we did yesterday with composite volume. So let me find the volume of this prism first. That's probably the easiest shape to do. So it is just a prism. So we do the area of the base, which is just a 10 by 10 square. So that would just be 10 times 10. And then the height of this prism is 32. So volume equals 10 times 10 times 32, which means this is a 3,200 cubic foot prism. So then on top here we have a pyramid, and we haven't used this formula yet, but it's very similar. We have I said pyramid. I said prism. It's 1/3 the area of the base times the height. So very similar, it's just a third. Since this is 10 down here, I also know the dimension here is 10. And same here, since this bottom is 10, I know this top is also 10. So when I go to find the volume of this thing, I would have to do the area of that base, which the base is just a square. So I would just do base times height or length times width. Or sorry, I forgot the 1/3. 1/3 times the area of the base, which is just 10 by 10, times the height of this entire pyramid, which I do not even know. So let me show you why I don't know that, because you might be thinking it's the 12. But it's not. 12 is what we call the slant height. When we go to the doctor, we do not measure ourselves slanted. We measure ourselves straight up and down. And we've seen something similar to this in another homework problem we've done. But you can make a little right triangle here, and we can solve for this missing height. So let me get a little triangle off to the side here. Where are my shapes? Triangle. Just so it's not so messy inside there. Let me rotate this around. Okay, so I just drew this triangle off to the side. Let's label what we know. So I don't know the height. That's actually what I'm looking for. So I'm going to go ahead and put an H right here. This is my height. Here's my right angle. They gave us the hypotenuse, right? They gave us the slant. The height was 12. So I know this is 12. And then here's where you have to be careful. This is only half the base. So we know this entire thing across was 10. So from the middle out, it's only going to be 5, half of 10. All right, so now we're going to use the Pythagorean theorem because we have a right triangle. We know 2 out of the 3 sides, so we can use the Pythagorean theorem to get our height. So we're going to do the height squared plus 5 squared equals my hypotenuse, which is 12 squared. So I'd have height squared plus 25 equals 144. Subtract 25 to the other side. I get the height squared is 119. So the height, I'm going to just write it, is the square root of 119. If you want to find the decimal, you can. I will. I sometimes just leave it as a square root. So we get that the height is about 10.9 feet. So that is the height of my pyramid. So now I can go ahead right here, and where I was going to plug in for H, for how tall my pyramid is, I can put 10.9. So now on a calculator, I would do 1/3 times 10 times 10 times 10.9. You should always be multiplying 3 dimensions together. That's how you get your cubic volume. So 363.3 for the volume of the pyramid. So that's cubic feet. So that's the volume of the pyramid. Then I have my volume of my prism. So my composite volume, my total volume, would be 3,200 plus my 363.3, which is 3,563.3 cubic feet. So just add the volume of the bottom plus the volume of the top to get your final answer. And that is that one. All right. This next one, same thing, composite volume. I'm going to find the volume of the bottom part and add it to the volume of the top part. So we just have a prism again down here. So we do the area of the base times the height of my shape. So the base is just a 5 by 5 square. So I would do 5 times 5, and the height of this is 4. So 5 times 5 times 4 is 100 cubic inches. So that is the volume of the bottom portion. And this top part is a cylinder. Again, this is now our first time using this. And it's really just like the area of the base times the height. It's really the same formula because our base is a circle. And the area of a circle is pi r squared. So these formulas are really the same thing. You really could just memorize that for any type of prism. So our base is a circle, so that's why it's pi r squared times the height of it. So when I do the volume, I would do pi times my radius, which is 2, squared, times the height of the entire cylinder is just 1. So go ahead and type pi times 2 squared times 1 technically, and you get 12 point, around it to 57 cubic inches for the volume of that cylinder. So now our total volume would be the 12.57 plus 100, and it would equal 112.57 cubic inches. And that's the final answer there. All right, last one is the volume of just the shaded part. Again, same exact thing as what we did with area. You're going to do the volume of the entire big shape here, which is a cylinder, and subtract out the volume of the other shape, which is a cone, to get just the volume of the shaded. All right, so to do the volume of this cylinder, remember it's pi r squared times h. The radius is this 3.5, and the height is 7, and that's the same for the cylinder and the cone. So let me plug what needs to go in, and I would have pi times my radius is 3.5 squared times the height, which is 7, and I'm going to subtract out the volume of a cone, which is 1/3, and I'm getting this from over here. It's 1/3 times pi times your radius squared, which is still 3.5, and the height of the cone is still 7. So now if you plug that in your calculator, pi times 3.5 squared times 7 is about 269.39, and then subtract out, that's 1/3 of that. Subtract out 89.80, and when you subtract those two, you get about 179.59 cubic inches as your answer. So just do the whole thing minus the cone to get just the shaded. All right, sorry I'm rushing. I have 2 minutes. All right, this is actually from your homework assignment. I just wanted to do one of the word problems with you. I know word problems can be scary, but I promise this isn't much harder than, or most of them aren't much harder than just like a basic problem. Excuse the drawing. So the radius in number 11 is 4. They say the height is 9. And it wants to know how the changes from in A and B affect the volume. So real quick, I'm going to find the volume of this initial shape. So the volume would be 1/3 times pi times my radius squared times my height, which turns out to be 150.8 cubic centimeters. So that's the volume of the initial shape. For A, it says, what if I double the height? So I'm going to double the height. So instead of it being 9 in my formula, it's going to be 18. Everything else stays the same. So I'm just doubling my height. When I put that in the calculator, I got 301.6. So let's see how that affects the volume. Well, it's now 301.6, and if I divide it by what it initially was, it's now 2 times bigger. That's what happened to my volume. My volume got 2 times bigger by doubling my height. And then for the radius being doubled, so instead of it being 4, it's going to be 8. So again, keeping everything else the same, my height's going back to 9. I would get 603.2. If I take this volume divide it by what it initially was, I see that it got 4 times bigger by doubling my radius.